Hello everyone, and welcome back to our channel. Today, we're diving into an essential topic for engineering and design students, third angle projection in isometric drawing. By the end of this video, you'll understand what it is, where it's used, its benefits, and how it connects to orthographic and isometric views. Let's get started. Third angle projection is a method of representing a 3D object in 2D using orthographic views. Imagine you have a 3D object, like this cube. To show it on paper, we use multiple views: front, top, side, and sometimes rear or bottom. In third angle projection, the object is placed in the third quadrant, and the views are projected onto planes as if you're looking through the object. Here's how it works. The front view is the primary view. The top view is placed above the front view. The side view is placed to the side of the front view. This arrangement is standardized and widely used in engineering drawings. Third angle projection is most commonly used in the United States, Canada, and other countries that follow the ANSI American National Standards Institute standards. On the other hand, first angle projection is more common in Europe and countries following ISO International Organization for Standardization standards. So, if you're working in the US or Canada, you'll likely use third angle projection. But it's important to know both methods, especially if you're working on international projects. Now, let's talk about the benefits of third angle projection compared to first angle. 1. Intuitive layout. In third angle projection, the views are arranged in a way that mimics how you see the object in real life. For example, the top view is placed above the front view, which feels natural to most people. 2. Widespread use. Since it's the standard in the US and Canada, it's easier to collaborate with industries in these regions. 3. Clarity. The projection lines don't overlap as much, making the drawing cleaner and easier to read. On the other hand, first angle projection has its advantages too. 1. Global standard. It's widely used in Europe and ISO-compliant countries. 2. Compact layout. The views are arranged in a way that can save space on the drawing sheet. So, the choice between third angle and first angle depends on your location and the standards you're following. We can construct an isometric view from orthographic views. If you have to orthographic views like the front and side views. We will discuss this example later, but for now, let's start with a simple example and make it simple. You can construct an isometric view. Here's how. 1. Start by analyzing the orthographic views to understand the object's dimensions and shape. We have to give in views, as we can see. Since this is a front perspective, we can determine the object's width 5 mm from the front, height 5 mm, and depth 5 mm from the side view. 2. Use the measurements from the orthographic views to draw the isometric axes 30-degree angles. Three. Plot the points and connect them to form the 3D shape. We must construct a 3D orthographic view of the box after creating a 3D isometric box using the specified dimensions. The side planes are added to the 3D box by step, and we expand them using the top and front side views. Thus, give plane name A, B, and C before drawing planes. We needs to set a specific distance from plane A in order to reach plane B, which is next to plane A. From either front or top viewpoints, the distance we travel from plane A is gate. The lines from plane B are aroused by the final plane, which is plane C, as is usual. The extending distance can be seen from the front or top side, as we have the end plane from plane C next. At last, we get the end plane next to plane C, which extends the lines from plane C as normal. The extending distance is visible from the front or top side. You made a nice observation when we were creating these planes, if you notice that the planes that were visible from the side turned into lines when viewed from the top and side. To clarify the late sight perspective of the plane C, why does it appear as a line at the front and top? I explain you through everything step by step, starting at the top and making our way through to the front. This is trick that you can use to read the drawings. Now the last plane D, is remain to compilate plane drawing. So draw a last plane in the way that cannot change, or that cannot bring the change on the side, and other views. The last view is the same shape with C, but it moved from by given distance. Now that the side planes have been drawn, the next step is to connect them. To do this, we look at the front or top views, as this is where the extruded lines are visible. But when we move to the side, these lines become points because they have distorted. So compare the front and top to draw the lines. Lastly, cut off any unnecessary lines, which means the lines heading on the plane have to be removed to make the object seem like this. This process is called orthographic to isometric conversion, and it's a fundamental skill in engineering drawing. It allows you to visualize the 3D object from its 2D representations. Alright, everyone, that's where we'll pause for now in example 8. We've made some great progress, but there's still a bit more to cover to complete this drawing. Don't worry, I'll be back soon to wrap up this example and take you through the final steps. If you have any questions or need clarification on what we've covered so far, drop a comment below, and I'll be happy to help. Make sure you're subscribed to the Drawing Solution channel and hit the notification bell so you don't miss the next part. Thanks for watching, and keep practicing your third angle projection skills. Until next time, happy drawing!